Thank you for the kind introduction. So when you think about vulnerabilities in Android, you probably think about vulnerabilities in apps or about vulnerabilities in Android itself, right? And there are a lot of studies that have studied how vulnerabilities in these areas are handled once they are discovered, what the characteristics of these vulnerabilities are, and so on. However, there's also the chipset inside your smartphone that enables it to do all its basic functionality, like running Android itself, but also, for instance, enabling cellular connectivity. And there we currently lack a large-scale study, which leaves a lot of open questions, such as, do different chipsets made by the same manufacturer share vulnerabilities? Who discovers chipset vulnerabilities? Is it the companies who make these chipsets, or is it external researchers like bug bounty hunters? Also, what are the typical timeframes until vulnerabilities in this area are mitigated? And many, many more. To understand this a bit better, we first need to understand what a smartphone chipset really is. The core component is the application processor. This is where the Android lives. And then you have a bus and a bunch of co-processors like the cellular baseband or the Bluetooth modem. On each of these co-processors, there's a dedicated firmware that's specifically built just for the one purpose of this co-processor. There's also a driver for each of the co-processors that's running on the application processor and that enables Android to leverage the functionality that's offered by the co-processors. And the hardware, as well as the drivers and the firmware, are not made by smartphone manufacturers. Instead, they are made by chipset manufacturers. And then the smartphone manufacturers acquire the chipsets, the drivers, and the firmware, integrate them with additional peripherals such as antennas, displays, camera, obviously battery, case, their customized version of Android, and build a smartphone out of this. All right. And well, how do vulnerabilities end up in chipset, drivers, and firmware? They are typically introduced by accident, obviously, during the development process at the chipset manufacturers. And then the chipset ends up in smartphones, which are analyzed by researchers. This can be academic researchers, this can also be bug bounty hunters, and this can also be the product security teams that the chipset manufacturers employ. Once a vulnerability is found, hopefully the chipset manufacturers are informed, and they will analyze the vulnerability to assess which chipsets are affected, what the severity of the vulnerability is, and then they will develop a patch. Now, they cannot roll out the patch themselves. Instead, they supply the patch to the smartphone manufacturer, who will package the patch into an over-the-air update. This is the same functionality that also typically updates the Android that's on your smartphone. And this is then deployed via an over-the-air update to the smartphones in the hands of end users. Now, the problem of this chipset vulnerability lifecycle, as we call it in the paper, is that all the information that you need to understand this process and to understand what are the results of each of these steps are scattered across the websites of the involved parties. You have information on the chipset manufacturer website, on the smartphone manufacturer website, and also partially on the Android project's website. Now, what we did to combat this is we developed a knowledge base. And this aggregates information from Android security bulletins, the websites of chipsets and smartphone manufacturers, the national vulnerability database, and product databases into a knowledge base of more than 3,600 chipset vulnerabilities affecting more than 430 chipset models by all the large manufacturers. These 430 chipset models are used in more than 6,800 phone models. And we also have information on about 18,000 smartphone updates. And on the one hand, we store this in a database, but we also generate a website out of it, which gives you an overview on the data, but also allows you to drill into specific information. Like you can drill into a specific vulnerability and have a look at all the affected chipsets, for instance. And this website and this data set is also continuously updating. So the numbers I gave you are the numbers we had at the paper, but they have since, for instance, already increased because obviously time has gone by and new vulnerabilities were found. All right, now let's have a look at some of the insights that we can draw from our data, starting with the vulnerability introduction again. So what we found is that for any vulnerability in any given chipset model, well, no, the other way around. For any given chipset model, 93% of vulnerabilities you can already find in a previous chipset model by the same chipset manufacturer, and only 7% of vulnerabilities are newly introduced. Likewise, we've also seen that 91% of these vulnerabilities will then persist into future chipset models, while about 9% get removed. And the insight here really is that you can look at legacy functionality, because that will persist on and on and on across chipset generations, and you will still find new vulnerabilities. It's not always the best idea to only look at the latest and greatest functionality when looking for vulnerabilities. Likewise, I mean, what probably is happening here is that a lot of the legacy functionality like LTE or GSM or older Wi-Fi standards, for instance, they are not re-implemented for every chipset model, right? The chipset manufacturers are probably like carrying on this functionality across generations, which totally makes sense from an economic perspective. Why reinvent the wheel every time? However, that means once you find a vulnerability, the chipset manufacturers have to go and look at every one of their products to figure out where this code went and which chipset models are affected. Because typically, when you find a vulnerability, you will tell them, we found it in this particular chipset. But now they have to figure out, okay, like which other of our products are also affected by this, which is potentially time consuming. And I will come back to this in a minute. Next, we look at who finds vulnerabilities. And what we found is that Qualcomm and Samsung in 2023 were able to find more than 50% of vulnerabilities via their own product security teams in-house. In comparison, MediaTek and Unisoc found less than 25% via their own product security teams. The numbers have changed a bit in 2024, and you are invited to have a look at the website to get the latest numbers there. However, in general, we would say that there's generally a very high reliance on external researchers. There are bug bounty programs to keep external researchers attracted. However, this is also a bit worrisome because there's still no guarantee that external researchers will continue to look for vulnerabilities and also report them to the chipset manufacturers. But there's also quite a positive note. All of these chipset manufacturers have a system in place in which you can report these vulnerabilities. And judging from the numbers, the vulnerabilities are also taken seriously and are being accounted for and are being published at some point. So nobody is trying to sweep vulnerabilities under the rug, so to say. Okay, let's look at a bit at the timeline in which things happen. Once a vulnerability is found, we've seen that chipset manufacturers are able to provide a patch for 25% of vulnerabilities within 91 days, but require more than 320 days to provide a patch for 95% of all vulnerabilities. Keep in mind, this only means that there's a patch that now the smartphone manufacturers can pick up and provide you an over-the-air update with. This does not mean that you can already go and update your phone. For this additional step, the smartphone manufacturers take 44 days to patch 25% of affected phones, but up to 266 days to patch 95% of affected smartphone models. This also means that there's quite a spread, right? So sometimes it happens that they release an update already for the first affected smartphone model, but take a lot of time to release an update for other phone models also affected. And this would enable threat actors to analyze the patch and potentially develop an exploit to attack those phones that are not yet updated and that cannot be updated yet by the users. So from our perspective, this says that updates are generally not very well coordinated across different phone models. 90 days and the 90-day disclosure period is also almost never adhered to. And there's no single party at fault here, since kind of both like the smartphone manufacturers and the chipset manufacturers regularly do not meet the 90-day deadline. but we should think that should at least spark a discussion in our community whether this 90-day deadline that's mandated by academic conferences, but also in a lot of industry context, really makes sense in this area. Maybe it's just not long enough. All right, zooming out a bit. We also have some additional use cases that we think our data set can enable in the future. First of all, you can use it to identify trends. You can find out which components are likely to yield severe vulnerabilities because they have yielded severe vulnerabilities in the past. But you can also find which components do have relatively few vulnerabilities. Maybe these components will warrant more scrutiny. Since we've seen that there's a lot of code sharing going on, our website also has a tool that allows you to build a diverse set of smartphones to test your new methods on, so your vulnerability discovery methods. And this tool will basically try to design a set of, or give you a set of smartphone models that you should test, which uses chipsets that do not have very large overlapping sets of vulnerabilities. Lastly, what our tool also allows you is to determine how widespread a recently found vulnerability is. So if you have ever found a smartphone vulnerability, you will know the problem that you get a CVE and you can list all chipsets that are affected by this vulnerability on the website of the smartphone manufacturer. But what you couldn't do is find out all the smartphones that are now affected by this vulnerability. And this is something our website enables. And with this, I would like to end my talk. I invite you to take a look at the paper, which offers a lot more information than I was able to give you within these 12 minutes. Also, maybe have a look at the website, and I'm open for questions. Thank you very much.
Let's thank our speaker. Excellent talk. Any questions from the audience? Excellent. Go ahead.
Hello, very nice talk. I have a quick question. So you mentioned that you're able to tell which smartphones are affected by a specific vulnerability. What is your methodology for doing that, and how reliable it is?
So what we do is we basically collect the information from all of these websites, right? And once you have a CVE, this chipset manufacturer will list all affected chipset models. So we take this list of chipset models, and then we have a database of which phone uses which chipset model. And from there, we get a list of, by combining these two, we get a list of affected smartphone models. So there's no heuristic or anything involved. I would say it's pretty reliable. The only issue is if our information on which chipset is used in which smartphone model is wrong, which is unlikely, but not impossible.
Okay, so you're not actually looking at the code at all?
No. We're just aggregating information that's public and linking it together.
Okay, so what if, let's say, a specific brand has applied the patch earlier than perhaps another brand? How would you be able to tell?
So what I meant by vulnerable is has been vulnerable before it has been updated. To figure out if a smartphone is vulnerable, we also download update change logs for some smartphone brands. And based on that, we can also tell you if a specific phone model is still vulnerable, but only for the brands for which we have update change logs, which is more than 50% of the smartphone market. But well, it's a handful of brands, so to say, because there are a few large ones.
Okay, thank you.
All right, very good question, very good answer. Anything else before we continue on? All right, one more. Go ahead.
Thanks for the talk. I'm Rinzi Zhang from Georgia Tech. I have a quick question. I see you answering previous question, most of the information is you automatically gathering from the chip developers and the chip manufacturers. So I just wonder, is there any plan or future plans you plan, the researchers can actually actively reporting that in that case we can skipping the long period before the manufacturer funding and really releasing those patches? Thank you.
So you mean whether we would offer a way for somebody to report a vulnerability to us?
Yeah.
No, there are no such plans. And I think this is also potentially a bit dangerous because that would mean we would sit on a pile of chipset vulnerabilities where nobody has an update yet, right? So we only publish stuff where at least there's a patch, because if there's no patch, then it's not on the chipset manufacturer website. And yeah, otherwise we would sit on a pile of unpatched vulnerabilities, which is probably not good.
Okay, thank you.
Okay, we'll move on to our next paper. And let's thank our previous speaker really quick.